Now, we are understand what exactly the machine learning algorithms are worth. Let us consider we have some training data consists of the input, also known as a feature, and the output that is called as a label. So in machine learning algorithm, these are the keywords we have to use, that is a feature and the label. So what do you mean by the features in a machine learning algorithm? The features are nothing but the input parameter you are giving to the machine learning algorithm. And whatever the output is given by the machine learning algorithm is called as a label. So input is nothing but the feature and the output is called as a label. Let us consider this example. Here you can see there is a one red and apple. So what are the features we are considering from this image? So I find out the three features. First, the color. Second, the size. And third, the weight. So as its color is red, its size is medium, and the weight is 50 grams. And when you give this information to the machine learning algorithm, the machine learning algorithm understands this feature and it will give the output as a label that, hey, it is an apple. Because these features are more matched with their trained data set, and the trained data set say that if the item having the color red, if its size is medium and its weight is near about 50 grams, so you can be called it as a apple. This is very basic example. It is not exactly machine learning is work, but this is a very basic example. Now, let's consider how the machine learning is work. So to understand in detail the machine learning algorithms working, so keep in mind that every machine learning algorithm requires a training data. The training data has some input and expected output. That is called the label data set. So in machine learning, there are the two types of data sets. First is called as a unlabeled data set and second one is called as a labeled data set. So here we are giving the training data set as a labeled data set. So what is a labeled data set? So labeled data set say that if there is a x1, so the output will be y1. If there is a x2 is the input, the output is a y2. If there is a x3 is the input, the output will be the y3 and so on. So this data set we are giving to the training algorithm. The first step in machine learning algorithm is that we have to provide a training. And for that training the algorithm, we require the data. In training example algorithm, we are giving the relationship between the x and the y. And this relationship is nothing but the mathematical expression. We will see in our coming lectures. So this mathematical relationship you have to use between the input and the output, means x and the y. Here let us consider I am giving the one mathematical relationship, that is y is equal to fx. F is any function. So y is a output based on the function f. It has the input x, where predict the y for the new instance that causing the y equal to fx. And this is called as a learning algorithm. Machine learning algorithms are basically divided into the three types. First is called as a supervised learning. Another is called as unsupervised, and third type is called as a reinforcement learning. In supervised learning, we will see the classification and the regression. In unsupervised learning, we will learn about the clustering and dimensional reduction. While the reinforcement learning is nothing but we have to understand the real-time decision system, robotics, skill acquisition, learning tasks, and the game of artificial intelligence. So let us see the one by one. What are the different types of machine learning algorithms? So this is the supervised learning. What do you understand from this diagram? In this image, you can see that there is a one person. He is trained under the supervision of his guru or rishi. So his rishi has given some instruction to that particular person, and under his supervisor, under his supervision, that person is trying to perform some task. So this is called as a supervised learning. What do you mean by the unsupervised learning? In unsupervised learning, here you can see that the person is not work under any supervision. He is to learn himself and he is perform his task on his own decision. He is not he has not taken any decision of his supervisor. He is performing his task on the basis of his own decision. So this is a very famous story of Mahabharata. In the supervised learning, that person is nothing but the Arjun. The Arjun has get training under the supervision of his guru, and he is called as a great Arjuna because of his skill. While in unsupervised learning, that person is nothing but Eklavya, and the Eklavya is learned himself. He is not getting any supervision from the guru, but still he is a good archer as compared to the Arjuna. And these are nothing but machine learning algorithms. I hope you now understand what is a supervised and unsupervised learning. So in supervised learning, there must be some supervision, and in unsupervised learning, there is not any supervision. The machine learning has to take its own decision in unsupervised learning, while in supervised learning, the machine learning algorithm has given some input by his supervisor, and on the basis of that input, the machine learning algorithm will be worked. This is the history of machine learning. So you can see that machine learning is a part of artificial intelligence, or you can say that it is a subset of artificial intelligence. In 1950s, artificial intelligence has been started by one of the very famous experiments by the tuner, that is called the tuning experiment. The aim of tuning experiment was to identify if the machine can give the answer to the human being, and it was performed by the scientist Alan Turing in 1952. In 1980s, the machine learning concept has been started, while in 2010 onward, a new concept that is called the deep learning has been born. The deep learning is a subset of machine learning, while the machine learning is a subset of artificial intelligence. The machine learning or artificial intelligence program has been started by the Wendell and Lee in 1980 and 1980. They predict the recovery rate of the pneumonia patient in 1917. Using one of the algorithms, they are giving the pneumonia patient prediction. Earlier, 1980 has detected the fraud used that is done in a credit card, drive autonomous vehicle on public highway. Cesario in 1992 and 1995 play a game such as backgammon at the level of approach to perform in the Human World Championship. According to the author Samuel, the machine learning algorithms enable the computer to learn from the data and even improve themselves without being explicitly programmed. Where machine learning is a category of algorithms that allows the software applications to become more accurate in predicting the outcome without being explicitly programmed. So in machine learning, we don't want to concentrate on programming more as compared to other programming. Here, we have to select the accurate algorithm that will implement on the machine learning, or implement on the database. Basic message of machine learning is to build algorithm that can receive the input data and use the statistical analysis to predict an output while updating the output as a new data that becomes available. So let us consider this is a specific definition of machine learning. What does it say? Let us consider the computer program said to be learned from the experience E. A computer program is said to learn from the experience E with respect to some class of task T and performance measure P. So here E is representing the experience, T is representing the task, and P is representing the performance. If its performance at the task in a T as measured by the P into the experience E, it can be written as, for example, the computer program that learns to play a checker might improve its performance as measured by its ability to win at the class of the task involving playing a checker game through the experience obtained by playing a game against itself with the experience E. how it is worked. The machine learning algorithm as compared to the traditional program is totally different. And how it is different? Let us see. In traditional programming, we require the data and the program. For example, if you are use the C or C++ program, so you have to write a program in a C or the C++, and then you have to provide the data. For example, if you want the addition of two numbers, so you have to write down the program either in a C language or any programming language, and then you have to provide the value to that variable. For example, A equal to 10, B equal to 20. So that the code will execute and it will perform the mathematical operation on it, and it will give the output C equal to 30. Where the behavior of program is defined by the programmer. So it is totally based on the programmer's logic. So if programmer has a good quality of knowledge about that program and its logic, then and then they can be performed and give the proper output. But in machine learning, you don't have to concentrate on the program, where you have to concentrate on what you are given to as the input, that is the data, and what you are expected. You have to give this data information to the computer, that is a data set, and what is your expected output. To the computer has now given you the program, that is your machine learning algorithm. So this is the basic difference between the traditional programming and the machine learning. So what is the learning problem? In general, to have a well-defined learning problem, we must identify these three features. First, class of the task, what is the task you have to perform, then measure of performance to be performed, that is P, and source of experience, that is E. Now check the learning problem. Let us consider I have the one task is playing a checker. Is my performance percentage of gain that is won against the opponent. On the basis of that, my performance will be calculated. What is the training experience? Training experience say that playing a practice game against itself. So here I am getting my task. My task is playing a checker game. My performance is percentage of gain won against the opponent. And my training experience, that is playing a practice game against itself. So let us consider one example and let us try to explain this using the formula. So there is one problem of handwriting recognition. So what is the task? My task is recognize and classify the handwriting word within an image. So you will get the one image, and from that image you have to recognize and classify what are the handwriting words that are written by the writer. The performance, the percentage of the word correctly classified. In our previous example, we have seen that. The training experience. There, for training experience, I am providing the data space of handwriting word with a given classification. For example, Let us consider this is an image and you have to find out what is written in this image on the basis of machine learning. So here my task is recognize and classify the handwriting word within the image. My performance is to find out the percentage of words correctly classified, where my experience is the database of handwritten words with a given classification. So you can see that from the word we are performing the wake me up this. So for this there is a percentage that this is more accurate than the Thai practice and Thai, where the morning is more accurate than the move, having, running and the other. So using this performance we can classify that how much accuracy is provided by our algorithm. So today we stop here, and in the next lecture we will see the more example on learning problems.